Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about mission control instructions and flag manipulation instructions. So, this is one of the classification in the instruction set of 8086 microprocessor. So, in order to make programming for 8086 microprocessor, addressing modes and instruction set of that particular target microprocessor is very important. And the programmer should also have idea about the architecture of that particular microprocessor, because while doing the programming, we will be using the registers that are available in the architecture of 8086 microprocessor. So before using that registers, we should know what are the general purpose registers and what are the special purpose registers and what is the size of the register and how the general format is indicated and what is the function of each register. Now, so here in this session, we have to discuss about mission control instructions, flag manipulation instructions. First, coming to the mission control instructions. Okay, so these instructions will control the machine. So here machine is nothing but CPU. We can also call it as a processor. That means the instructions that comes under this mission control instructions classification, they will be controlling the processor. Now, so here these instructions controls the bus usage and execution. So how the bus should be used and how the instruction should be executed. So all these operations can be done by using this program control transfer instructions. So bus usage means whether the bus should, what instruction we have to use in order to lock the bus, what instruction we have to use in order to give the system bus access to the other masters. Okay, so all these conditions related to bus usage will be coming under the classification mission control instructions. And so these instructions are also called processor control instructions because these instructions will be controlling the processor. Now, coming to the flag manipulation instructions, these instructions are related to flags. Like here, the flags that comes under this classification, the instructions that comes under this classification will be related to some flags like interrupt flag. Okay, how to set the interrupt flag, how to clear the interrupt flag. Okay, that interrupt flag will be coming under the control flags. Okay, so 16-bit flag register format will be divided into conditional flags and control flags. But among the 16 bits of the flags, only 9 flags will be used. In that 9 flags, 6 flags comes under conditional flags and 3 flags comes under control flags. Okay, so here among all that 9 flags, what flags that are related to this flag manipulation instructions means, one is interrupt flag, how to set the interrupt flag and how to clear the interrupt flag. Okay, so that interrupt flag will be under the control flags. And next related flag is direction flag. How to set the direction flag, how to clear the direction flag. If the direction flag is set and cleared, what is the operation that will be performed? Okay, so these instructions are related to the direction flag. Okay, this direction flag is also related to control flags only. And another instruction related to the flag manipulation is carry flag. Okay, so what instruction we have to use in order to set the carry flag? Okay, in order to clear the carry flag. So all these instructions comes under this flag manipulation instruction. So this carry flag instruction, carry flag and all will be coming under the conditional flags. Okay, so the flags related to these 3 instructions, that is interrupt flag, direction flag and carry flag. So the instructions coming based on these 3 flags will be coming under this flag manipulation instructions. Now, so when these particular instructions are executed, they are going to modify the status of the flags directly. Okay. Now, let us discuss about this mission control instructions and flag manipulation instructions. Okay. So, the first instruction that comes under this mission control instruction is WAIT, wait instruction. So, what is here WAIT instruction means? Wait for test input, wait for test input to go low. Okay, so when this wait instruction is executed, it represents wait for test input to go low. That means it is related to test bar signal. Okay, so we know that 8086 microprocessor is having 40 pins. Okay, so among the 40 pins, one of the pin is test pin. This instruction is related to the test bar pin. So wait for the test input to go low. Now, next mission control instruction is HLT. So HLT instruction represents halt. Okay, so HLT represents halt the processor. Halt the processor. And next mission control instruction is NOP. So NOP represents no operation. So generally this NOP instruction and all we will use in order to produce the delays. Okay. So NOP represents no operation. And next mission control instruction is ESC. Okay. So ESC represents escape. Now, so this ESC instruction and all, it is related to the coprocessor. Okay. So ESC represents escape to extend device like coprocessor. Okay. So this ESC instruction and all we will use when more processors are available along with the main processor. Now, next instruction is LOCK. So LOCK represents lock. So this instruction is used to lock the system bus access. Okay. So LOCK represents bus lock instruction prefix. Bus lock instruction prefix. So all these instructions comes under mission control instructions. That means all these are related to bus access and execution. Okay. So when these instructions are executed, they are going to control the machine, which is nothing but processor. Now, let us discuss about each instruction in detail. Okay. So here in the mission control instruction, the first instruction is wait. Okay. So as we have seen here, wait represents wait for the test input to go low. Okay. Now, so coming to the wait instruction here, it represents wait for test input to go low. Okay. So for example, when this wait instruction is executed, 8086 microprocessor will be entering into the ideal state. So processor entering into the ideal state means it will not perform any instruction. It will not do any work. Okay. So when this wait instruction is executed, the processor will be entering into the ideal state, which we can also call as tri-state or high impedance state also. Okay. So here the processor is going to insert wait state in the instruction cycle. So as we know, in order to execute one instruction cycle, 4 clock cycles are required. Okay. So T1, T2, T3 here, in order to execute one instruction cycle, so totally 4 clock cycles are required. One is T1, T2, T3 and T4. Okay. So if the instruction is complicated, we have to use this wait instruction. Okay. So when this wait instruction is executed, what it is going to do means it is going to insert wait states. So wait states will be indicated as TW. So this wait states will be included before the instruction T4. Before T4 cycle, TW wait states will be inserted. Okay. So now like this wait states will be keep on including before T4 cycle until unless test bar pin goes low. Once this test bar pin goes low, again it comes out and no wait states will be inserted. So that is why here wait state means wait for test input to go low. That means the processor go on inserting the wait states in the instruction cycle until unless the test bar pin goes low. Okay, once if it goes low, wait states will not be inserted. Next cycle comes T4. Once if T4 is executed, it represents that the instruction cycle or one instruction has been executed. Next. So here, when this wait states are inserted or when this wait instruction is executed, the CPU will be in the ideal state. Okay. It will be ideal state till test bar pin goes low. And again, when it is going low, the program will be, that means the next instruction will be executing continuously. And here when this wait instruction is executed, it is not going to show any effect on the flags. And the general format of this wait instruction is WAIT. So totally here, when this wait instruction is executed, wait states will be included before T4 during the instruction cycle until unless test bar pin goes low. And next mission control instruction is HLT. Okay, HLT represents halt. Okay, as we know, HLT represents halt the processor. Halting the processor is nothing but making the processor not to do anything. Generally, what the processor will do first, the processor executes the following steps in the sequential order like fetching, decoding and executing. When this halt instruction is executed, the processor will not do anything. That means the processor will stop fetching, decoding and executing operation. Okay. So if this instruction is executed, the processor will be entering into the halt state. Now, so entering into the halt state means the processor will stop fetching, decoding and executing all the instructions. Now, so here, in order to come out of this halt state, we have two ways. Okay, so the two ways are here to pull out the processor from the halt state. So what are the two ways means? One way is we have to reset the processor or we have to interrupt it. So these are the two ways in order to make the processor come out of the halt state. And next, coming to the general format of this halt instruction, HLT represents the general format. Okay, so halting the processor. So totally this instruction, when it is executed, it is going to halt the processor. No operation will be done. No fetching, decoding and execution will be done. And next mission control instruction is NOP. Okay, so here this NOP instruction represents no operation. Okay, so here the name itself says NOP, no operation. No operation will be done. So processor is not going to do anything. So generally this NOP instruction and all we will use in order to produce the delays. Okay, so if you wanted to write any delay program which is related to the main program, you have to write that by using the instruction NOP. So when each NOP instruction is executed, okay, so it is going to have 4 clock cycles. It is going to include 4 clock cycles. 4 clock cycles delay it is going to provide. Okay, so until this 4 clock cycles execution is completed, it is not going to do any operation. So operation like whatever fetching, decoding or executing or any arithmetic or logical operations, nothing will be performed. So up to 4 clock cycles execution. Okay, so no registers contents will be incremented, nothing will be done. But except here, it will be keep on incrementing the value of IP by 1. Okay, so when this NOP instruction is executed, only IP contents will be incremented by 1. So as we know, what are the contents that will be stored in IP register means IP register, instruction pointer register. So it is going to hold the address of the next instruction that is going to be executed. Okay, so everything will be ideal, but only the contents of IP will be keep on incrementing by 1 automatically. Now, so here the IP value will be keep on incrementing by 1 up to 4 clock cycles. So one time if you are using the instruction NOP in the program, it provides the delay of 4 clock cycles. If you wanted to provide more delay, you have to write NOP instructions accordingly. Now, so generally this NOP instruction is used to provide the delay in the instruction in the program. Now, similarly, when this NOP instructions are executed, it will not show any effect on the flags. Now, so the general format of this NOP instruction is NOP. So totally, this NOP instruction is going to produce the delay of 4 clock cycles in the program. And next mission control instruction is ESC. Okay, so ESC represents escape to extend device like coprocessor. So escape to extend the device like coprocessor. So this ESC instruction and all will be used when coprocessor is there in the CPU. Okay. So here, when this instruction is executed, it frees the bus for an external master like a coprocessor. So in order to release the system bus access to the requested master, okay, so how the system bus access will be released to the requested master means, if this ESC instruction is executed, the system bus access will be released to the requested master. Okay, so that requested master can also be called as coprocessor. So coprocessor is nothing but an additional processor that is present in the CPU in order to perform the special tasks, additional tasks like extended arithmetic operations and all. Okay, so here coprocessor means additional processor used in some computers. So coprocessor means it is an additional processor that will be used in some computers. So what is the purpose of this coprocessor? What is the function of this coprocessor means here? So here in some computers to perform specialized tasks such as extensive arithmetic calculations. So any arithmetic operations that should be done extensively. Okay, so this is the purpose of the coprocessor. So when the processor wants to release the system bus access to the requested master, it can release by executing the instruction ESC, escape instruction. Now, so the general format of this ESC instruction is ESC. Okay, so escape to extend device like coprocessor. And next mission control instruction is here lock. Okay, so here this lock represents bus lock instruction prefix. Okay, so here when this lock instruction is executed means, suppose if the processor, though there are requested processors requesting the system bus access, if the processor is doing some work and if the processor is not willing to give the system bus access to the requested master, it can lock the system bus access to the processor. The processor can lock the system bus access so that the bus access cannot be given to any other masters. Okay, so the locking of the system bus to that particular processor only will be done when this lock instruction is executed. Okay, so generally this lock instruction and all we will use as a prefix to other instruction, Now, so this lock instruction, it is used as a prefix to another instruction. Now, so when this lock instruction is executed, the bus access will not be allowed to any other microprocessor unless the lock prefix instruction is executed completely. Once if the instruction is executed completely, then only the lock instruction will be released. The system bus will be unlocked. Now, so this instruction is used in case of programming for multiprocessor systems. So for example, if any computer is having multiple number of processors, there is a chance of requesting the bus access. The co-processors may request the bus access to the main processor. Okay, so in that case, if the main processor is not willing to give the system bus access, we have to execute the instruction called lock. Now, so if you take here lock exchange semaphore comma AL. So here exchange is the actual instruction, but here lock is a instruction which we are using as a prefix to other instruction. Okay, so when this lock exchange semaphore comma AL instruction is executed, what is the function that is going to perform means, here the exchange instruction requires, here the exchange instruction, generally this exchange instruction requires two bus accesses. So in order to perform the exchange operation, it requires two bus accesses. So if you are writing this lock instruction as a prefix to exchange instruction, unless these two bus accesses are completed, the system bus will be locked to that particular instruction only. Okay, so the exchange instruction requires two bus accesses. The lock prefix prevents this lock instruction, what we have used, this lock instruction prefix prevents another processor from taking the control of system bus, between these two accesses. Okay, so generally exchange instruction requires two bus accesses. So if you are writing this lock as a prefix to this exchange instruction, the bus will be locked between these two bus accesses. And so that is what about this machine control instructions. So all these are the instructions that will be controlling the machine. That means they are called processor control instruction also, because here machine is a CPU, which we can also call as a processor. Now, coming to here, flag manipulation instructions. As I told you, these instructions will be used in order to manipulate the flags. Okay, in order to set or reset the flags like interrupt flag, direction flag and carry flag. So coming to this flag register format, in this flag register format, as we know, it is a 16-bit register. But among these 16 bits, only 9 flags will be used. So what are the 9 flags here means this is the 0th flag. That means carry flag it is. And here this is parity flag. And AC represents auxiliary carry flag. And here the 6th bit represents Z. It is 0 flag. And here the 7th bit represents S. It is sign flag. And here 8th bit is T. It represents trap flag. And here the 9th bit is I. Okay. So it represents interrupt flag. And the 10th bit is D. So D represents direction flag. And here 11th one is O. Okay. O represents overflow flag. So whereas the flags like 15th bit, 14th bit, 13, 12. Okay. So this 5th bit, 3rd bit, 1st bit. So all these bits are undefined. Only 9 flags will be used in this flag register format. So among these 9 flags, some flags comes under conditional flags. Okay. And some flags comes under control flags. Now, so coming to the conditional flags, what flags comes under conditional flags means, so here this is CY, P, AC, Z, S, okay, O. These are the 6 conditional flags. Okay. And here coming to the control flags, here the control flags are only 3 control flags. The 3 control flags are here T, I and D. Okay. So here CY represents carry flag. Okay. So P represents parity flag. And AC represents auxiliary carry flag, or simply we can call as auxiliary flag. And Z represents 0 flag. Okay. S represents sign flag. And here O represents overflow flag. Okay. So here these are the 6 conditional flags. Now coming to the control flags, we have only 3 control flags. 3 control flags is T. So T represents trap flag. Okay. I represents interrupt flag. And D represents direction flag. Okay. So these are the 3 control flags. So among these 9 flags, in the flag manipulation instructions, we are going to see the information related to, that is, we are going to see about the carry flag and interrupt flag and trap flag. So these comes under flag manipulation instructions. So these are the 3 flags we are going to use in order to discuss about this flag manipulation instructions. Now, so coming to the flag manipulation instruction, the first one is CLC. Okay. So CLC represents clear the carry flag. Okay. So CLC represents clear the carry flag. Okay. So clearing the carry flag, generally carry flag will be represented with CF or C. Clearing the carry flag means CF will be equal to 0. Okay. So if you wanted to clear the carry flag, you have to set the CF bit in the flag register format as 0. Okay. So how we can set that means by executing the instruction CLC. Now, and next flag manipulation instruction is CMC. So CMC represents complement the carry flag. Complement the carry flag. So complementing the carry flag means, for example, in the previous case, if CF is equal to 0, if you wanted to make it as 1, it is possible if the CMC instruction is executed. Okay, so the carry bit will be complemented when this instruction is executed. And next flag manipulation instruction is STC. Okay, so STC represents set the carry flag. STC represents set carry flag. Okay, so setting the bit means making it as 1, and the carry flag CF will be equal to 1 in this case. Okay, so these 3 instructions are related to a flag called carry flag. These 3 instructions are related to carry flag. So you can manipulate the carry flag bit by executing these instructions. And next flag manipulation instruction is CLD. So CLD represents clear the direction flag. Okay, so direction flag, it will be indicated as DF. So clearing the direction flag means DF will be equal to 0. So in order to make the direction flag bit in the flag register format of 8086, you have to use the instruction called CLD. And next flag manipulation instruction is STD. So STD represents set the direction flag. Okay, STD represents set the direction flag. Okay, so setting the direction flag means, setting means making it that bit as 1. So DF will be equal to 1. Okay, so generally when this DF is equal to 0, what happens when this DF is equal to 1 means, what happens means the processor will be executing the contents of SI and DI. That means it will be working in auto increment mode and auto decrement mode. And these 2 instructions are related to the direction flag bit. And next flag manipulation instruction is here CLI. Okay, so CLI represents clear the interrupt flag. Clear the interrupt flag. So generally interrupt flag is indicated with IF or I. So clearing means making this IF bit as 0. So if you wanted to make the interrupt flag bit in the flag register format to 0, it is possible by executing the instruction CLI. And next flag manipulation instruction is STI. So STI represents set the interrupt flag. Set the interrupt flag. Setting means IF will be made as 1. If you wanted to make the interrupt flag as set, then we have to execute the instruction STI. Okay, so here these 2 instructions are related to interrupt flag. Okay, so generally what is the importance of this interrupt flag means, for example, if any interrupt is coming through INTR signal, okay, so that interrupt will be accepted only when the interrupt flag bit is set. Okay, so we have to see that the interrupt is coming. In order to accept the processor, in order to accept that interrupt, we should also see that whether the IF flag bit is set or not. Okay, so for example, in another case, if interrupt is coming through INTR signal, for example, if the interrupt bit in the flag register format, if interrupt flag is not set, then that particular interrupt will be rejected by the processor. Okay. Now, so coming to this flag manipulation instructions. Okay, so we have seen different flag manipulation instructions coming under carry flag, okay, direction flag and interrupt flag. Now, we will see here STC instruction. So it represents set the carry flag. Okay. Now, this instruction is going to set the carry flag. That means the CF bit in the flag register format, it will be made as 1. And once this STC instruction is executed, it is not going to show any effect on the flags. And next flag manipulation instruction is CLC instruction. Okay, clearing the carry flag. That means CF flag bit will be cleared. That means it will be set to 0. So when this instruction is executed, it is going to reset the carry flag. When this CLC instruction is executed, it is not going to show any effect on the other flags. And next flag manipulation instruction is CMC instruction. Okay, so CMC represents complement the carry flag. Okay, so for example, if the carry flag is 0, when this CMC instruction is executed, this carry flag will become 1. In another case, previously, if the carry flag is 1, when the CMC instruction is executed, okay, so this carry flag will be made as 0, complementing the carry flag. One's complement. Now, so when this instruction is executed, it is going to complement the carry flag. The CMC instruction also, when it is executed, it is not going to show any effect on the other flags. So we have other flags also in the flag register. And the next instruction is STD instruction. Okay, so STD represents set the direction flag. So setting the direction flag means this DF will be equal to 1. Okay, so now when this STD instruction is executed, the processor will be entering into auto decrement mode. Okay, so when this DF is made as 1, the processor will be operating in auto decrement mode. Okay, so auto decrement mode means it is related to the contents of SI and DI generally. Okay, so this STD instruction and all we will be used generally during string operations. So you can use STD or we can use CLD. Okay, so when this STD instruction is executed, the processor will be operating in auto decrement mode. So auto decrement mode means the contents of SI and DI location will be automatically decremented by 1. So generally in the program, if you wanted to decrement the content of SI or if you wanted to decrement the content of DI by 1, we used to write the instruction called DEC SI, that is decrement SI or decrement DI. So instead of writing that every time decrement SI, decrement DI, again decrement SI, decrement DI. So instead of using the same instruction number of times, okay, so we can automatically decrement the contents of SI and DI by using the instruction called STD. So that is why this STD instruction, CLD instruction and all, they will be used during string operations. So when this STD instruction is executed, it is not going to show any effect on the flags, other flags. And we have another flag manipulation instruction, that is CLD instruction. Okay, so CLD instruction means clear the direction flag. So clearing the direction flag means making DF is equal to 0. Okay, so same as STD, the CLD will be operating in the opposite manner. Like this CLD instruction also we will use during string operations only. But when this DF bit is made as 0, it will be operating in auto increment mode. It will be operating in auto increment mode. Okay, so auto increment mode means here also it is related to the contents of SI and DI. So when the processor is operating in the auto increment mode, the contents of SI, okay, and DI will be automatically incremented by 1 every time. Like that, how many times the value of SI and DI will be keep on incrementing by 1 means until unless the counter becomes 0. It will be keep on incrementing, or if this STD instruction is used, it will be keep on decrementing the contents of SI and DI location. So it will be purely incrementing and decrementing the number of times or related to the CX value. counter value. Now, so here this instruction is used to reset the direction flag. Okay, so if the direction flag is reset, the contents of SI and DI will be incremented automatically by 1. So used during string operations. So when the CLD instruction is executed, it is not going to show any effect on the flags. And next flag manipulation instruction is STI instruction. Okay, so STI represents here set the interrupt flag. Set the interrupt flag. Okay, so here setting the interrupt flag means IF bit should be made equal to 1. Okay, as I already told, in order to accept the interrupt, we have to see that the interrupt flag bit also should be set. Like, so I have already drawn this. So if this IF bit is 1, then only the interrupt coming through INTR signal will be accepted. Okay. So this interrupt flag bit setting and all is possible if this STI instruction is used. This instruction also will not make any manipulation in the other flags. It will not show any effect on the other flags. Okay. So this enable INTR interrupt of 8086 microprocessor. That means the particular interrupt coming through the INTR signal will be accepted in that case. And next flag manipulation instruction is CLI instruction. So CLI represents clear the interrupt flag. Okay, clearing the interrupt flag. So clearing the interrupt flag means IF bit is made as 0. Okay. Now, so if this instruction is executed, the interrupt flag bit will be made as 0. Okay. So in the same way here, same. So if any interrupt is coming through INTR signal, okay. So if this IF bit is made as 0, that particular interrupt will not be accepted by 8086 microprocessor. Now, so due to this interrupt, in 8086 microprocessor will not respond to the interrupt signal that is coming through INTR input. Okay, is not responding means that particular thing will be rejected. Now, so the CLI does not affect any other flags. Okay, so this is what about the flag manipulation instructions and machine control instructions of 8086 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.